Okay, little sound test. Can I hear myself? And can I see some video? Show me. Show me, show me. Okay, little sound test. Sounds good. Perfect. So then let's close this one. Then let's open up the chat, which is also working. Great stuff. So welcome back to the stream where we are creating a platformer from scratch using LibGDX and Kotlin. Today we are on day 8. Actually, it's day 12, I guess. Hey, Joby. And today we are going to implement some shader stuff, which means that basically the player, which currently when he takes damage, he is blinking a little bit. And that is not cool enough. We want to have some nice effect that maybe he is blinking in a white color or red color, whatever color we choose. And since that is not possible with just a normal LibGDX functionality that we have, so that you can color, of course, a sprite and tint it and everything, but you don't get the effect that I'm trying to achieve. I explain it in a moment. So that's why we will need some shaders. By the way, I changed something yesterday. So first of all, currently when we get hit, this is how it looks. So we just blink a little bit, we lose 1 life, and that's it. So it's not that fancy. And for this blinking, I want to have a white effect and maybe also play a different animation for the player. But let's see how difficult that is. We finalized yesterday the different enemies, or not different enemies, it's just one of them, this rocket, which can move to the left, right, bottom, and will deal some damage when he gets in contact with the player. So all of that is working. And I optimized one small thing. Let me open up the Git history so that you can see that as well. The most important thing is, I think, in here. Yes, let me make that a little bit bigger. So yesterday, as you might remember, we created this different states for the rocket, and there I had some hard-coded numbers in it. Let me also open those up. So there we had something like this rocket attack range, which was a hard-coded number of, I think, 5. Yes, it was 5. And somewhere else, we also had this number 7 in here, which I did not like because that's not really to make something flexible. And what I wanted to do is actually that the range for the detection and also the attack range should be in relation to the size of these sensors here, so the horizontal and the vertical sensor. And I simply took them into account now. So our component that we had yesterday, this aggro component, has an additional range value. To be even better or more precise, it should be actually a vector 2, so that it has a range on the x and the y axis that we should consider. But I did not need that for now. So for simplicity, it's now just one value, this float. And there was a little bit of a problem because unfortunately, a fixture definition in box2D, also the real fixture, there I cannot easily get out the size, so the width and the height of the shape. That simply did not work that easily, because a box returns a polygon shape and there just have the vertices, and I would need to know then which vertices or the distance between which vertex would be the width and the height and so on. And that's why I made a little bit of a workaround, which in my opinion is good enough. So we had this custom class, this fixture definition user data, where we had the box2D definition and the custom user data that you can also add. And there I simply added a size information now. And I also just set that where we created different shapes. So for example, maybe here in the ellipse, there's a good example. they are now also pass the width and the height to our own custom fixture definition class. And with that little piece of information in hand, I can then, when we create this aggro component, I can get our fixture definition. I filter in that case for the one which is an aggro sensor, which has the specific user data. If there is none, then there is something wrong, because then we are trying to add an aggro component without the sensor, which does not make sense. So there will be an error. And if there is something, then simply the range would be the maximum of the X and Y axis, which in that case, for example, if it's the horizontal sensor for whatever reason, which is the first one, then we will take the width here as a range. And if it's the vertical sensor, then we would take the height, which is the bigger one of those two. And with that, we have then more dynamic values and not those hard-coded values for the sensors, attack range, and stuff like that, which is a little bit better. Not perfect, but I think it's good enough for our game. Okay, so today what we want to start with is a damage shader. And for that, since I am not an expert with shaders, so also there I always need to learn something new. But I saw a video once and I saved that somewhere, I think in the videos that I like, or maybe that I want to view later on. Yeah, it's the one that I want to view later on. So we will watch a video where we will learn from that little guy here, Game Endeavor. Let me link it and to give some credit to him. I'm not following that channel, but I think it's just some Godot related stuff. And one of the shaders that I did in this, how did I call that? The proof of concept, where I'm dissolving sprites and recreating them. That shader was also, if I remember correctly, inspired by one of his videos, and I just translated it to my game. The main difference, or maybe to explain some basics, so in LibGDX, a shader is always consists of two programs. Or two parts. We can check that out in the sprite patch. There is a default shader function, and the shader always consists of a vertex shader and a fragment shader. And the code that we see here, so those comments here, or the strings actually, that's the content of the shader program, and that is what we are going to create. And one of those, I think it's the vertex shader, that one influences the, how can I say that, the shape most likely of what gets rendered. So a sprite is usually just a rectangle, which has 4 vertices or 6. Normally it's sometimes it's triangles, which means one rectangle would be 2 triangles. But I'm not sure, maybe that is optimized and it's just 4 vertices, so just one rectangle. And you could modify the locations of these vertices, so the different points of the rectangle, with a vertex shader. That would be the first part, but that one we are not going to influence, so there we keep it as it is. The more important part, where you can do actually a lot of things, is the fragment shader, and that is sometimes called the pixel shader, which is, in my opinion, a good explanation. It's basically manipulating or telling your graphics card how to render a specific pixel. And there, I think it's called a fragment and not really a pixel, because one pixel of your texture could represent multiple pixels on your screen, depending on resolution, viewport, and stuff like that. And most likely this relation between the pixel of the texture and the pixels on the screen, maybe that is called a fragment, but not 100% sure. The important part that I just remember is fragment is modifying the pixels, so the colors, and the vertex shader is manipulating somehow the shape itself that gets rendered. And yeah, we are going to develop here something, and I try to translate whatever he's now explaining to us to LibGDX. There is one thing that I remember in Godot. I think they have a special, or they have sometimes special variables in their shader language that they can use. So they have some built-in stuff We don't have that, so we just have basic OpenGL stuff, I would say. So there we need to check out if we can translate it. But let's watch the video first. I will also hide my camera that you see everything.
The best way to give feedback to your player is to flash the graphics of an entity to communicate that something has happened. For example, if it has taken damage, the player has interacted with it, or just to add a little extra juice to your UI. Howdy, and welcome to Game Endeavor. If you want to learn practical dev skills and improve the quality of your games, then subscribe and ding-a-ling that bell. You may have used the Canvas Node's modular property to modify a sprite's color before. This works in a pin.
Okay, one moment. So this thing here, what he's showing there. Wait.
Modular property to modify a sprite.
Okay, so that one here that you can actually tint the sprite or give it a different color, that functionality we have available in LibGDX. So with the color information of the sprite, we could also modify it like this. But as you can see, it's just like overlapping colors or really tinting. I think that's the correct word for it. So you don't get a completely white or completely red sprite, so where you don't see any of the other colors in here. I just want to have the shape of my character, but I want everything to be completely white or completely red, for example. And that one we cannot achieve with the built-in functionality of the sprite. The reason is that maybe... Okay, wait, let me turn on the camera once more. So first of all, let me quickly get these programs into separate files, and it's a little bit easier to explain. So we will have a separate folder that we will call shader, and there will be one file which is the default dot is it vert for vertex shader and frag for fragment shader, if I remember correctly, but not 100% sure. We would need to check that. Then we need to remove certain lines of code here. So I hope that one here appears multiple times. Let's remove it. Then, yeah, that's a little bit of work now to remove the Java code and get just the normal code that we need. So all the pluses here, we also don't need them. They're just related to the Java code. And finally, that stuff here. Let's also remove it. Looks a little bit better. And now we need to replace these constants here with the real values. So shader program, that is called a position. Then there is a color attribute, which is a color. I will explain that in a moment, what all of that stuff means. We need a semicolon, by the way, at the end, if I remember correctly. And then also a texture coordinate attribute, which is called a text coordinate. Okay. For whatever reason, there's also a 0. I could imagine, is it like this maybe? And then missing semicolon, then here the underscore, and here the semicolon. And then let's reformat it. And that should be it. Let's make it like this. So if I remove, there's still something missing. This is, that was a color. That was texture attribute 0. And then we had the position. I think something like that most likely. Okay, so in shaders, what you basically have is attributes, uniforms, and varying attributes. I cannot remember 100% what is the difference. So if I remember correctly, but please correct me if I'm wrong, an attribute itself is just related. Oh no, the attribute itself, let me give let me check one more thing. I remember one of these attributes get passed through the different shaders, so through the vertex and the fragment shader. The uniform, that one I know for sure. That's the one that you pass from outside, so from your program. Like this matrix 4, which is called projection transformation. That is the camera or the viewport that we used in some of our rendering calls. If you remember correctly, or if you remember it, when we say map render use or patch use or whatever, when we render something, what is actually happening, let me quickly show you that, is that we set a view. And what is a view? A view is that we set on the sprite patch here, we set a so-called projection matrix, which is from our game camera, this combined matrix, which by coincidence is a matrix 4. And basically this matrix 4, so how does our viewport look like? How should things get transformed and everything? So this matrix 4, this projection matrix, is basically this uniform here. This U project transformation. So uniforms get passed from our program or from our code to the shader. Then varying, if I remember correctly, those are the ones that get passed through the different shaders. So if we set a value here, like we set here V color to some specific value, then we can also access that in the fragment shader later on and modify it. And attributes are, not sure, attributes which are just related to that program itself, or it's some generic OpenGL attributes, but they are not 100% sure. Yeah, let's also create the, because I think we need that, the default fragment shader file to have some basic setup, which would be this little piece of code here. So here again, let's get rid of all that stuff. Then let's get rid of these things here. And that one. And I think that's it. No. If definition OpenGL ES, I have some. Then define low P as low P, precision medium, float P. I don't know. Or maybe I don't have the OpenGL extender. Extension installed could also be the case. Not 100% sure, but maybe I need to remove here something more. Anyway, in our fragment shader, we basically have here this little part here, if I remember correctly, is to make the shader compatible with different backends. So the shader support on your phone is a little bit different than the shader support on your computer, for example. And there you just define the precision for the floating point numbers, if I remember correctly, which is that part here. So if this GLES is defined, not 100% sure what that is, then we define the low precision with something. Otherwise, we define it a little bit differently. I just know this block here helps a little bit with the compatibility of the shaders, that it also works then on Android phone. At least when I had some problems adding that block, that worked then. And in the end, again, some varying stuff. And there we should be able to see now some different, some things that we saw before. Let's check. So V color and V texture coordinates, which is also here, V color and V texture coordinate. Okay, so varying means, so that's the one that I did not remember. Those are the attributes which get passed through the different shaders. The first one is the vertex shader. There we would set the color with which we want to draw a pixel, let's say, to the screen to keep it very simple. And the second one would be the texture coordinate, which is basically when we have a texture, we need to pick a specific pixel out of it that we want to draw. And these two information, so where is this pixel and in which color do we want to paint it or draw it? This is this V color and V texture coordinate information. And the result of the vertex shader is this OpenGL position. So this is some mathematical stuff with the projection transformation matrix and the position of the vertex. And somehow it then knows where to render it on the screen. And the second part would be the fragment shader. And there we then calculate this GL frag color, so that the color of the fragment that we are going to render. And that is currently the color from, in our case, it would be the color of the sprite multiplied with the color that we have on our texture at the given texture coordinate. I explained it later on a little bit better with a real example with a texture, but for now, that is the thing that we need to remember. So we have a vertex shader and a fragment shader. And the color that I wanted to mention, so that's why we cannot get the completely red color, because the default color calculation to render something to the screen is the color of your sprite multiplied with the color that we have on the texture. And that's why you cannot get it completely red. That's why you get the behavior like you see it here. So you have the bear with maybe some brown colors, and that multiplied with a red color gives you a result like this, but not completely red. Okay.
Color before. This works in a pinch, but likely doesn't give you the effect that you desire, and may even look a little muddy in my opinion. To achieve the effect that we want, we're going to be using a very simple little shader instead, so let's get started. Since we're using a shader, we're going to need to add a shader material to our graphic. This is what will apply the shader to our entity. If you're using multiple...
So in my opinion, we don't need that. So we don't do anything with materials. We don't have that. In our case, it should be something different.
Sprites and want this to apply to all of them. But what I like to do is apply this material to the body's root node. And then I can tell the individual nodes that they should be using their parent's material. This will run the shader code on every canvas item that has this property set to true.
Okay, wait.
Inside of the shader material, we need to add the new shader. Doing this will open up the shader panel beneath our main window, and this is where we'll be writing our shader code. I haven't covered shaders on this channel yet, but don't be intimidated by it. The code we'll be using is very similar to GScript, and we won't be doing anything fancy. The first thing we're going to do is define what type of shader we'll be using. This shader will be going onto a canvas item, so we'll be using the shader type, canvas item. Take note of the semicolon here, it's pretty important. One of the big differences between this shader language and GDScript is that each line of code needs to be ended with a semicolon.
So all of that he mentioned so far is Godot specific in my opinion, so we don't really care about whatever he needs to do here. We will handle that differently.
The shader we'll be creating needs to run for each and every pixel on our sprites, and this is done inside of the fragment method, which we'll create by saying void fragment. A few more differences already. The void here is the return type for the method. Godot's shading language.
So it seems like most likely this will be the fragment shader that I explained before. I would assume that's just the default fragment shader. Oh no, sorry. Fragment shader is the one with the pixels, right? So this is the one that we need to take care now ourselves. So there we need to see or pay attention what he's doing.
Which means that the variables and methods that we use need to have their type defined, unlike in GDScript where a variable could be anything at any time. Think of this as the static typing features that were added to Godot in 3.1. Also, we're required to enclose our code blocks within curly brackets. We won't be getting into this, but this is also true for things like if conditions and various types of loops that you may use. The goal of this shader is to take the sprite's color, a value between 0 and 1, and use these to blend our natural color with the flash color. To do this, we first need the color for this particular pixel. We can get this color by saying vector4 color equals texture UV. That vec4 here is like a vector2, but 4, so don't get too excited. And
okay, I would say here he mentions that he wants to get the color of the texture, which is actually what we already do. So in our case, it would be that little call here. So texture 2D, U texture, V texture coordinates. That's the one. That's the line of code that he's currently showing in the video, I would say.
Texture constant is something that Godot provides us with so that we can access the graphic of our sprite. And the UV just tells Godot where to find the pixel in the texture that we want to use. To set this as our color, we simply say color equals color. Well, of course nothing has changed. We just said color equals color. If I pointed to Paul Bear over there and said cartoon bear, I sure hope I wouldn't be blowing your mind either. If you must test that the shader is actually doing something though, then we can play around with this color property. For example, we could remove the blue from the pixel by saying color.b equals 0.0, and you'll notice that the sprite's color changes. Also,
okay, let's try that. So let's do it step by step. Let's also try that. Because we will need a little bit of basic setup, because testing out this shader now in the real game with all the additional stuff that is happening and the special render logic that we have in the render system and so on, that can be a little bit tricky and hard to understand and debug then what is happening. So what I prefer here is a separate test class, most likely a test screen that we already have, and there we test that specific shader here. But before we continue, let me quickly go into one of the projects where I previously already extracted the default vertex shader. And let me just quickly compare that. So let me get that into the clipboard. And then I think in IntelliJ I can compare with the... Can I not compare with clipboard? Something like that? Not sure. Let's see. Does anything change? That's the wrong one. I want to be here. Okay, I have the uniform at a different location. And I see the underscore is not correct. So I had texture coordinate underscore 0. But it's basically just 0. So that's the correct version here. And then let's also fix the header of the dissolve shader. So that part here, because that is important. Otherwise we get some exceptions or errors when we start up the shader and do something. So let's see. Then here we have that part here. And we don't have the dissolve stuff, and also all of that stuff is not necessary. So we just have this basic calculation. Okay, then I would say, first of all, there is obviously a missing extension. Maybe I never installed that one. Let's see, there should be an extension for that. It's under plugins, I guess. And then let's search for shader GLSL. Plugin support for GLSL. Aha, I have that installed. Okay, but it seems like it's confused by something. .frac.vertex. Let me see. Can I... override file type. So this is GLSL. Okay, it already detected that. Okay, but for whatever reason, it seems like it does not like this assignment here at the top, but I'm pretty sure that that one is working. Let's see, we will try that out. So what we need, first of all, is a special screen to test that. So let's call that let's make that here the shader test screen. And that one we just said is a normal screen. And finally, in our test launcher in here, there we would need the shader test screen. Okay, and what do we need in here? So for sure, we need a render method. Then we need a dispose method. And what we really need is, let me think, first of all, a sprite, which is a sprite, and there we just take as a graphic maybe our frog, I would say. So can I pass here a texture? Yes, I can. So that should be texture, and that is equal to a texture, and there I think I just pass the path, which would be graphics, objects, and then frog.png, and that's the one that we pass to our sprite, and we need to make sure that we dispose the texture. And what else do we need? We need, of course, also a sprite patch, which we also need to dispose. And finally, in our render method, we can have something like batch use, and there sprite draw with the sprite patch that we have. And to correctly draw something, we also need a viewport, which is, for example, a stretch viewport in that case. And the world width is 16 by 9. And we have here viewport apply, and here we pass in the viewport camera. And we need one more thing, I think. Let me see. No, we are having a test game, which is a KTX game, and that one already clears the screen. I think that should be it. Maybe, let me see. So show needs to be overwritten, resize needs to be overwritten, that we also update our viewport. Okay, and in show there I would say sprite set position to 1, 1. The size is, I don't know, 2 by 2. And let's see. So this should hopefully render now our frog graphic just normally. No, file not found. Graphics, objects, frog PNG. It's object, not objects. Okay. Let's remove that. Okay. So we see now here our sprite. That's good. And what we can currently do, just that you see that we can set a color. And for example, just give it a red color. And the effect that we get is now something like this. So it's now tinted in red, but not completely red. Okay. So that's also working. Then what we want to do is we want to test our shader. So we will have something like our shader, and the shader is a shader program in LibGDX, which consists of a file handle for the vertex shader and a file handle for the fragment shader, which in our case is, how's that called? GDX? Or is it internal? GDX internal? I cannot remember. It's like this. Okay, and the path would be a shader path and then default.vertex. And another one, I'm pretty sure there's a KTX extension for that. I need to check that. The other one would be shader default.fragment. And with a shader as well, it is important to dispose it. Is that already it? So from what I know, a shader is compiled or errors or something. You can check if there was a problem when this shader was loaded, but I cannot remember anymore if that's already happening when you create an instance. Not 100% sure. Anyway, I am looking for something. File handle in libGDX. Isn't there something like file internal? Let me quickly check something. It's not important for our scenario here, but I want to know something. Is it most likely in the app extension file stuff? Profile, no. This is just some profiling, it seems. What else could it be? Graphics? No, doesn't make sense that it's part of the graphics extensions. So we had app, free type collections, inject log, math, preferences. Preferences maybe? Nah, then let's forget about it. Let's load it like this. So we have here our shader program, which we are already disposing. And what we can do is batch set shader equals to our shader. There is something to keep in mind. So whenever you change the shader, then a flush of your sprite batch is happening. And then it basically restarts or starts another draw call and texture binding and things like that if you do some other drawing afterwards. So whenever you change the shader, then a flush is happening. That is something to keep in mind. Okay, one more try. Okay, so that seems to work, but let's see if that is really working. So what we want to have here now is something like gl rec color dot red equals 1, for example. I think my extension or my plugin for OpenGL files is a bad one. Okay, so there is now something wrong. OpenGL does not allow... okay. So then let's make it like this. Okay, still not working. Undefined variable glFrec color. Yeah, we need to write it correctly, of course. Okay. And is this maybe 255? Not sure. I don't know. Not sure if it's between 1 and 0 or 255. I think it's 255 and 0. But we can already see that our shader is doing something because the representation now is different than what we had before. Okay, so that little setup is already working. Looks good. Then let's continue with the video. Oh, sorry. I get a phone call. I'm back in a moment. Give me 5 or 10 minutes. And I'm back. Sorry, that was an important call that I was waiting for, so I had to pick up the phone. Okay, so we are back at our shader, and there we tested something with the color. I think there is then also some built-in stuff in OpenGL where I could say something like this. So 0, 0, 0, 0, and 255, 0, 54, 55. Let's see. Let's see what that gives us. It's actually exactly the same. Interesting. So that should be alpha here at the end. Ah, wait, I said that like this. It should be like this. Okay, that crashes. No uniform with name uTexture in shader. What does that mean? I have no idea. Maybe it does not work like that, but let's see. Then let's make it like this. I'm not an expert again with shaders. And RGBA, I would assume. Then let's make green 0, blue 0, and let's try again. Nah, that's still crashing. No uniform with name uTexture. That would be this one. Let's comment this out. Also not working. Where the problem is related to what exactly? It's like everything is crashing now. No, that one is working. I don't know. Would need to check that. How to set RGBA in OpenGL shader. Just to play a little bit around and learn something. Aha, you see, it should be like this. So vector 4, and then I can pass in the different values, it seems like. Okay, maybe also AI could be very useful here. Let's see. Let's also remove that one here. I have following fragment shader. Can you change it so that GL frag color is equal to 100% red, no green, no blue, and alpha to 50%. Let's see if it can do that. Certainly, here is the modified fragment shader where GL frag color is set to 100% red, blah, 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 blah. Aha! Okay, so seems like it's a value between 1 and 0. And not the one that I had before with 255. Let's try once more. No, that one is for whatever reason not working. There it tells me no uniform with name uTexture. But why do I get this error? Fetch uniform location. Do I miss something? Let me also just compare it with what I did a couple of weeks ago. What did I do there? So I had the dissolve shader, which I loaded via the assets. Yeah, that is what we will do later on as well. But what else did I do? So batch use. Aha, I set it the shader inside batch begin. Okay, maybe it's a problem with our render code. Let's see. So maybe the shader, whoops, the shader needs to be set inside the begin and end call. Let's see. No, that does not make a difference at all. Then what else do I have? I updated the assets to load the shader. How did I do that? Because maybe there is a problem with the shader itself, that the syntax that we are using has a problem and it's not compiling properly. So let me quickly look at how I loaded a shader. So it's shader program apply. Then finish the loading, but there should be, here below, verify shaders and, let's make it a little bit bigger, verify shaders and init shader assets uniform location. Okay, so we get the shader, and if it's not compiled, I should check for that. Yeah, okay. Let me see, we will do that in maybe the show method here at the beginning. So if it's not compiled, shader, how will we call that? We will call that, what is the name actually of the shader? Does that have a specific name? A flash shader, okay. Flash shader could not be loaded. Could not be compiled. And there we get the log from that shader. Okay, let's see if that's currently our problem. No uniform with name uTexture. I don't understand that. And it's happening when I add that specific line of code here, right? So that one is working, but when I do it like this, then I get this error. And obviously it says fetch uniform location, because we have here a uniform. I don't get it. I don't really get it. Question, do I also need to call shader begin and end or something with the rendering? Maybe there I'm doing something wrong. Otherwise, we will check the documentation in a moment. Let's see here once more. So I have the dissolve shader, and what am I doing with that in my code? If shader, shader use. Then I set here some uniforms. Aha. But I don't set here this other thingy because that's set inside the sprite patch. So in my opinion, this is not really necessary, or is it? I scale it, I set the origin, I set the uniforms. Yeah. That's it. Otherwise, I just draw the sprite. Set the shader to null at the end. Draw it again. Yeah. I don't see the error. And I'm actually setting the shader also here outside. So there is not really a problem with that. I am not 100% sure why I get this error. No uniform. Really no idea at the moment. Anyway, let's go here. And let's do something here as well. So below here, if GDX input is key just pressed, keys, let's say num1, then the batch shader is equal to our shader, and let's call that the flash shader. And otherwise, if it's 2, then the batch will use the default shader. Okay, to verify that, we also need to, here again, we just set the red color to 1. Let's try that. So when I press 1, I have our shader, and if I press 2, I have the normal shader. Okay, so that works. Then let's continue and see if we can finalize that somehow.
Notice the 0.0 here. Color is a vector 4, and the vector 4's value are strictly floats. Recall the whole statically typed bit. We are required to use float values here, which we do by making it a decimal value. Also notice the B here. This is what defines the blue value of this color. We can also use R for red, G for green, and A for alpha. When you're satisfied, remove that line of code and we'll move on. Now we need to modify our color so that it flashes. For this shader, we're going to allow the possibility of defining a color externally, in case you ever want to have a different colored flash. We'll do this by creating a uniform variable outside of our method. Specifically, we're going to say uniform vec4 flash color hint color vec4 1.0. The vec4 1.0 is the color white, since it will be setting the red, green, blue, and alpha to 1.0. If you want to define...
Okay, wait. That was too quick. Let's also do that. So I don't know if we need this hint color. Not even sure if we have that available, but it makes sense that we have wait, let me get rid first of all of this plugin. For whatever reason, it's annoying me a little bit because it's not doing what I think it should do. So let me uninstall that one and then let's restart. Okay. So now we just have a normal text file. And let's see, is there another extension available for OpenGL? GLSL support. Version something. What is the latest version here? Shading language. That's the one that we need. That has way more downloads than the other one. Let's quickly check the plugin homepage. Versions last year in January. Yeah, let's try it out. Maybe that one is better. Looks a little bit better. Okay, then let's have here the uniform, which in our case would be, what is the GL fragment color? Is a vector 4, right? Let's ask the AI. What is... in the fragment shader code, the GL frag color variable determines the final color of a pixel on the screen. By setting it to we achieve the desired color. What is the type of GL frag color? Is it vector 4 or something else? You're correct, is of type vector 4. Okay, so if it's not hallucinating, we just trust it. So we will have here a vector flash. Let's keep it consistent with the other naming, so flash color, something like that. And that one we will pass from the outside. Which then means, let me think. Yeah, let's keep it simple. Maybe we don't need the texture here at all. Let's remove that for a moment. Let's remove that one here for a moment. And let's just make the GL frag color equal to our flash color. Okay, and since it's a uniform, we need to pass it, and that one we can do in our render lot. No, not here. How did we call it? Shader test screen. So here we would now do if batch.shader equals our flash shader, then we will use it to do something. And in our flash shader, there is a uniform for matrix. No, I think it's this one. Let me see. Set uniform matrix, set uniform vector, uniform F, uniform I. I guess we have a uniform for floats. Something like that. The name would be the flash color. And the value would be a float array of, let's make it 1.0 or 1, 1, 1, 1. Okay, what else? Offset is 0 and length is something. What? Set uniform F. There, just set a float. And here can set also a color. Okay, then maybe that one is the correct one. I don't know what 4FV means. And here we just pass, for example, color red. Let's try it like this. Here again, one thing to know. So when we set the uniform via the name, then the first thing that happens is that we need to look up what is the location of the uniform. So every uniform that we define, at least this is how I remember it, gets a unique index or number assigned to it. And when we call it by the name, which is, in my opinion, very intuitive and nice, but that has the downside that it needs an additional lookup for the uniform location. And we can bypass that later on in an optimized version. Where, as you can see it here, where we pass the location directly. And how do we get that? With the get uniform location and then the name, then we get the correct location. So we, in the optimized end version of our shader, we want to have the uniform location instead of doing it by the name. But for now, that should be it, I would say. So let's see. So now when we call that, we first of all have our normal shader, right? And when that one is done, so when I press 1, it crashes. Because I have this no uniform with name uTexture. What is that error? I don't get it. Why is it happening? Let's Google that. I never had this error before, I think. I don't know where that is coming from. LibGDX. LibGDX bright patch assumes that your shader will have uTexture uniform. To overcome, just add shader program pedantic equals to false before putting your shader program into this bright patch. Update. Ravish is right about shader compiler vanishing unused uniforms and attributes, but LibGDX wraps OpenGL shader in custom shader program. Not only should you add the uniform in your shader program, you should also use it. Otherwise, it will be optimized away by the shader compiler. But looking at your shader, you don't seem to need the uniform anyway, so check your program for something like uTexture 0 and remove the line. It should work fine then. Aha. So I don't want to use this U texture, right? I don't have that anywhere. It's commented out everywhere. But I still get the error because it's used internally. It seems like in the sprite patch. Yes, so here it sets set uniform U texture something. So it definitely sets this uniform, but since we don't use it, it gets optimized away by the shader compiler, if I understood the documentation correctly, which is not good. But it also seems like I cannot bypass that. So I would need a custom sprite patch where I override the setup matrices, or I simply need to use it, right? Because currently it gets optimized away, and I think I understand that now. So most likely when we have something like that, I could imagine that it also gets optimized away, because whatever I did here doesn't matter because I use here an equal assignment. Let me verify my theory. Yeah, it's crashing. That makes sense. And what if I do something like this? Still crashing because maybe it still somehow knows that I override everything from here. If I just override the... Okay, wait, let me modify it to this little code. Yeah, that one is working. Okay, so I understand the problem, at least I think so. The problem is that the LibGDX sprite patch always sets this U texture uniform. And seems like the shader compiler is pretty smart. So if it somehow identifies in our code that this uniform is not really used because we either override the result completely or don't use it at all, then it does not have this uniform in its compiled code. And therefore, of course, we can also not set it. Which means that the line that we had before, this one here, will fail because we did not use the texture. So we will watch the video now to the end. And one way to solve that would be that we override the sprite patch and this protected method, which I anyway find a little bit... no, I don't find it confusing. So it's doing the same stuff, but we would just need that line here. We don't need that one. So one way would be to override the sprite patch, or I'm not even sure, maybe we need the... how's it called? This U texture in our end shader, so we don't need to override it. But let's see, let's watch the video to the end. But at least I understand now what's happening here and what the problem was. Okay, then let's stop here everything and return to the video.
Setting the red, green, blue, and alpha to 1.0. If you want to define something else as the default color, then vec4 can take 4 arguments for each of these values. The hint color bit is for Godot, and lets us set a color when we're setting the shader's parameters. We also need a value between 0 and 1 that tells the shader how much of a flash to apply to our sprite. So we'll define another variable by saying uniform float flash modifier hint range 0 to 1 0.0. Nothing really exciting here, but the hint range will help us when setting our value externally and keeping it between the values that we want. Now we have the information we need to create our flashing shader, which is as simple as saying color.rgb equals mix color.rgb flash color.rgb flash modifier. This method takes the first argument and mixes it with the second argument by the giving amount defined by the third argument. So
okay, so that's interesting. See, I'm not sure if we have that available. Let me check that. The mix function in an OpenGL shader. Does OpenGL have a mix function? Yes, OpenGL indeed has a built-in function called mix. This function performs linear interpolation between two values based on a weight factor. The starting value of the range, which would be the color from our texture, then the ending value of our range, which would be the flash color, and the weight is how much of each of the colors it uses. If we have 1, we have the flash color, and if we have 0, we have the original color. Okay. Okay, then this should work, and we actually need then the original color. Then we need another uniform, which is a float. How is that called? Maybe a float, which we call f flash ratio or flash weight, maybe something like that. And what we have, so first of all, we get the original color of the texture. Yeah. And finally, not really. We have then a mix, as he mentioned, the mix of the original color, of the flash color, and we have the f flash weight. There we just need to make sure that that's always a value between 0 and 1. I guess there is also some built-in function for that in OpenGL. Let's see. How can I write the following code in GLSL? Float x is equal to the maximum of 0 and the minimum of 1 and some float value. Here's how you can write the equivalent code in GLSL. There is a clamp function. Perfect. So that's the one that we need. So we have then here the float weight, which is equal to clamp the flash weight between 0 and 1. And then we just pass here the weight. Semicolon. Okay, then let's come back to our test screen. What we now need here is another uniform, which we called f flash weight. And that one has a value between 0 and 1. We would, let's define that here at the top as well. So we have then a flash color. That's color red, for example. And we have a flash weight, which at the beginning is 0. Okay, then here we would pass in the flash color, and here we would pass in the flash weight. And now we need to play around with that a little bit. So let's say the number 0 resets the shader. That's the base scenario. Number 1 sets our flash shader with a flash weight of a quarter. Then number 2 sets it by 50%. Number 3 sets it by 75%. And number 4 sets it by 100%. So the expectation would be 0, just normal rendering. 1, that it gets a little bit tinted in the red color. Number 2 is 50% tinting. And number 4 would be that the sprite is completely red. That would be at least my expectation. Let's see. Number 1, crashing. No uniform with name flash weight. V flash weight in shader. V flash weight. How is it called? We called it F flash weight. I think that's actually not a good name. I just want to be consistent here. I think the V stands for varying and the U stands for uniform. So I think those should be U's. So the flash color should be a U and also the flash weight should be a U. And in our code, both of these are now called U, like that. Okay. Yeah, that looks a little bit better. That looks even more better. And finally, everything is red. Okay, very cool stuff. So this is already working in some way. Of course, it's not what we actually want because why do we have the behavior like this? So I give you a minute to think it through. So the original rendering looks like this. Then we have 25% mixing of the flash color, 50%, 75%, and 100%. But why do we get here a big red rectangle? And here we have the graphic of our player without the huge border. What is happening here? Think it through. And to make it even more funny, wait, I give you, how do you write the Jeopardy sound? Okay. So, what I think is going wrong, so I give you the answer. You had now more than enough time to think it through. I think the problem is that we actually are also mixing pixels which have a transparency of 100%. We are mixing it with our color, which is not correct. So transparent pixels also become the red color that we saw. So somehow here we need to exclude transparent pixels. So like if then we need the original color once more, because based on the original color we need to do something special. So let's call it the texture color, which is a vector 4. It's this one. And if texture color dot alpha equals 0, I guess, then do this stuff. I'm not sure if that is the correct syntax. We will see in a moment. Okay, it's the other way around, obviously, but that's also a cool effect. So now the sprite is black and everything around the sprite is red. Isn't that some effect that some games are actually using, where you don't, where they basically remove the entire color of the models? They are just appeared in black or white or whatever, but the background stuff remains the same. So maybe it's also some fragment shader stuff. Cool thing. So I think we need then 1.0, right? Yes, perfectly. Very cool stuff. Haha. Okay, let's watch the video to the end to give this guy then a shout out.
Flash
once
value
more.
of 0.5 will have a 50% mixture of the two colors.
But whatever he's saying now, we are not interested anymore because we figured it out ourselves how to do it.
Also notice that we're only setting the RGB values here. We don't want to mix the alpha value, otherwise the transparent pixels in our sprite will stop being so transparent and eventually become a solid block of color.
Ah, wait. Smarty pants. So we can optimize our stuff without the if condition, it seems.
Now we need to animate this, which is as simple as animating the parameters in our shader's parameter section. You can do this with whatever animation method you prefer. An animation player works great here. Now one of the things that you're going to notice is that the shader is going to apply to everything in your game. And while it would be OP to damage everything in the game with one hit, we only want to apply this effect to each individual entity.
Yeah, okay, that one is something that we figure out ourselves. But that's an interesting point. So we can actually just mix here. By the way, I did here a mistake. Let me revert that one more. Maybe it's, again, very simple. So what we need to do is we mix the... So RGB and RGB, then we only mix the RGB values. Is that already the solution? No. Flash shader could not be compiled. Expression left of RGB is not a struct. Ah, okay, wait, that one is not correct. RGB should be here. It's the result of this texture 2D. Flash shader, blah, blah, blah. Assignment of incompatible types. I thought so. So how did he solve that? Wait one moment. Let me quickly go back. So he gets the original color and then the RGB is the mix of something special. Oh, okay, I get it. So we need something like this. So GL frag color is equal to the original color. And then from this GL frag color, the RGB is equal to the mixture of the frag color RGB mixed with the flash color RGB and then the weight. Yeah, same behavior as before, but without the if. So that makes way more sense. That's cool. Then let's document that a little bit, what we are doing here. So first of all, get original color of texture. And finally, mix the RGB values of the original color with the given flash color. We don't mix alpha value to avoid that transparent pixels become non-transparent. Maybe something like that. Yeah, good stuff. Very good stuff. I like it. So to test that even better, let me think that through. So I will update the test screen a little bit some more, but that looks already very convenient. And let me make a little explanation now for those who are interested. So what is then really going on? There is a couple of things that I did not explain and that you maybe don't understand. So let me explain that to you. And for that, let's get let's get our texture atlas. I think with that one I can hopefully explain it. And let's get it from the map. This one? No, where is the... Is it this one? I don't know. I don't see the graphic for the map. Huh? Is it really just the terrain? Maybe it's really that one. Okay, then one moment. We are here and ah. Screw you, Microsoft Paint. Why can you not paste that in? Ah. Don't save it. Whatever it did now, I don't want that. Stop. No. I should open GIMP, but I'm even more lost in GIMP than I am in Paint. Okay, so now I have what I wanted to have. So what is happening? So there are a couple of things that are happening. So first of all, as I mentioned, and that is most likely the starting point, we have a game which has a specific window. So the size of this window might be like this. And in that specific window, we are rendering certain things, like, for example, the texture here that we have on the left side. But in addition to our window, we also have a viewport, which might be filling up that amount of space in our game. And this viewport simply has some information like the width of it, the height of it, the location where, so the X and Y value, maybe also some scaling, rotation. So all of this information, how the game objects or how things should be rendered in our game. So usually it's transformation, so that would be width, height, X and Y. Then the rotation and the scaling. I think those three factors. And for whatever reason, usually that is represented as a matrix 4 in math, which means you basically have a 4x4 matrix. And in total, you have then 16 values. And in those 16 values, there is this information encoded about the transformation, rotation, and scaling. And when we render something, so when we render a sprite, let's say like here, that would be our sprite, then this sprite has, again, a location, so a transformation information. It has a color, has rotation, all of that stuff is also encoded into the sprite. And this information is sent to your graphics card when we make the sprite batch draw call. And what we saw is then what is happening when we say draw in our program. We then tell our graphics card, hey, we want to render something. And to tell that to our graphics card, we need shaders. And the default shader to make all of that happen is already built into the sprite patch. That's why normally you don't need to deal with it at all. But that is something that is always happening in the background. There are even more shaders than that. There's usually a pipeline of different shaders where all this information that I just mentioned gets passed through. And in the end, the graphic cards then know I need to draw a black pixel at that location on your screen. And one thing that is related to a sprite is a texture like this. It could be also a texture atlas, like in our case. And I want to use that one here because there is an important information. So one piece of information in our shader was let me go to the vertex shader once more, was this projection transformation. And this is this matrix 4x4. And that is simply this viewport information that I mentioned before. So this transformation, scaling, rotation information, this matrix, how to render certain things on the screen, at least the shapes or the locations of the vertices, that is encoded in this 4x4 matrix, and that gets passed automatically by LibGDX with the sprite patch into this uniform projection transformation. Also important, the uniform is an attribute that gets passed by the program to the shader, so that needs to be set. And one part here is this projection transformation. The other parts, and that is the more important one for us, is in the fragment shader. And there we had this call here. So this texture 2D, where we pass in a texture and this texture coordinates that I did not explain yet. But basically this line of code here is extracting the color information of the pixel of the texture that we are currently going to render at a specific coordinate. And how does that look like? So as mentioned, we have a sprite, and this sprite might be linked to a specific region of our texture. So this here is the entire texture, so our texture atlas, and that is bound to OpenGL context when we are going to render something out of it. So then OpenGL is binding this texture, and we can then draw different segments or regions out of this texture here. And the sprite has the information that, first of all, it's linked to a specific texture like this one. And it also has the information to which region it's currently located. So let me cut off, I don't know, for example, that little segment here, and our sprite would be linked to this specific region. And there we have now two different coordinates. The first coordinate would be the position of the sprite itself, so the X and Y coordinate, but there is also the coordinate of the texture, so what kind of area of this texture should be rendered when I make a draw call to my sprite. And this is called the texture region coordinates. And they are usually called U and V. So you have X and Y for the real position, and then U and V for the texture coordinate position. And normally it's like this, that below here, that's the U axis, and the Y axis of the texture would be the V axis. And the value is between 0, which is the left edge, and 1, which is the right edge. So when we would look into our sprite, we will do that in a moment, then we will see it has some UV coordinate, and that is a value between 0 and 1. And you have then, I would assume, a bottom left corner of U and V and the top right corner of U and V, so that you get the rectangles, the region out of the texture that should be rendered. So most likely U1, V1, and U2 and V2, I could imagine. And this information, so this U and V coordinates, are part of this V texture coordinate information, so that OpenGL now knows with this texture 2D call, the first argument is the texture itself, which would be this entire graphic that we see here. And the second part, the texture coordinates, would be this U and V information that I told you, so that it knows, okay, we need that specific pixel here. So that one here, that would be, I don't know, U 0.2 and V 0.3, just made up numbers. So then it picks exactly that pixel here, which returns a color, so the color of that specific pixel, and that one is then rendered to the screen. But we are modifying that color, so here we get the original color of the texture, and we are then modifying this color by mixing it with the color that we set. In our case, it's a red color, and that's why we get then this render result that we just saw in our screen. I think this is hopefully the most important information that you need to understand what is happening here. Okay, and to give you now this information with the U and V coordinate, let's quickly go into the debugger. And here we have the sprite, and there we should hopefully see now some U and V coordinates. So we have the X and Y position, we have a width and a height. And here we have it. So we have a U and V coordinate and a U2 and V2, which in our case makes sense. Yeah, okay, because we have just the frog graphic itself. Let me show it to you. It's this one here. So we just have, this is our texture, and the sprite has the information that it needs to render this entire texture, which means U and V is 0, 0, bottom left corner, and 1, 1 would be the top right corner. But if we have a texture atlas, can I quickly show that? Yes, I can show that in the real game. There we have then different U and V values. Let me go to our render system, and there we have the render entities function, and let me make a breakpoint here. And let me quickly start up our game. Okay, so let me check this sprite here. I don't have access to it yet. Why? Maybe I need to write this code a little bit differently. Seems like it cannot debug it. Wait. Let's also fix that in a moment. Whatever. Let's do it like this for a moment. Okay, so here we have now our sprite, and I would expect here, yeah, so here you see something that now the sprite itself, I don't know if it's the frog or rocket or whatever, but if we check out our game object graphic, which is the different entities, we have this entire texture here. So where we have the U value from 0 to 1 and the V value from 0 to 1. And for example, the saw would be U value a little bit to the right, and V value should be, maybe it's actually the same, but not sure because of the padding. Maybe U and V is also smaller and bigger than 0 because of the padding that we have. So we don't actually go to the border or edges of the texture. We are a little bit inside. And that's why we have here, so we don't just have the value 0 to 1. We have then some values in between there. And this is basically describing the region inside our texture where we are. So the texture, you see it here, would be game object, and the region that we are going to render with the texture coordinate is that little piece of information here. Okay, good stuff. I hope that explained it, and I'm happy. So this shader is working. What we need to do now, and that can also be part of this test screen here. First of all, we want to load shaders with our assets. That's the first thing. And also I want to have that rendered a little bit more dynamic. So let's say we have two sprites actually. One would be the original sprite, and the other one would be the flash sprite. So we render both of these next to each other. So here, let's copy that one. Let's see. So we have an original sprite rendered at position 1, 1. And then we have the flash sprite rendered at position 3, 1. Same size. I think that looks all good enough. Let me check here one more thing. I got distracted. Never mind. So in the end, what we then want, we want to render original sprites, and then we want to render the flash sprite. The first one is quite easy. So there simply we set the shader to null. And then we say original sprite, draw with the patch. And then the flash sprite, there we are setting some uniforms with the flash color and the flash weight, and then we draw the flash sprite. Okay, so we don't need this debugging stuff here anymore. I think that's good enough. And finally in here we have the flash weight, and that one we simply increase by the delta time. And I would say, so if the flash weight is greater equal than 1, then we reset it to 0, for example, something like this. Okay, then let's see. That should hopefully work. Ah, that's the wrong one. We need our test screen. And we don't see anything. Very interesting. Let's get rid of the shader drawing. Ah, I did not set it. Okay. Wait. That's good. We forgot here to say that the batch shader is equal to the flash shader. Okay. Does that fix it? Yes. Okay. So now we see here the original sprite and here our flash shader where we are slowly increasing the flash weight to 1 and then resetting it to 0. Okay? Working perfectly. So the last thing is that we want to have the shader as part of our asset management, which means Grüß Gott, hallo Koptefisch. Hello. So what we need is an enum class that we call shader asset. And that one has two things. It has the vertex shader, which is GDX. What is it actually? Is it called a file handle or what is that? We get back here a file handle. Yeah, okay. So that would be a file handle. And we also have our fragment shader, which is also a file handle. And in here we have the default shader. We don't need that. We just need the flash shader, which has the GDX files internal. Yeah, it's basically those two things that we had here. One more try. Internal something. File internal. I'm 100% sure that there was a freaking extension in libGDX where you could write that in just one function name, this GDX files internal, but I cannot remember it and I don't find it anymore. I have no idea why. Good, so this is actually not the default fragment shader. That's actually the flash fragment shader. So that one we need to change. Hello, Vasto. And now when we load everything, I think here we would also load the shader assets, right? That would make sense. So for all of our shader assets that we have, we will load the shader program with it. And there we need to do something special. To internal file. You are maybe right. Maybe it was out of a string. Was it a string extension? To internal file. You are a god. Thank you for that. It made me crazy that I could not find it. It's an extension of a string and it's part of the assets extension. Also interesting. Very interesting. Okay, I had some example code in a previous project. So how did I load this stuff? There was some shader blah, blah, blah thing going on. I think we need this one here. Thank you, thank you. Made me crazy that I couldn't find it. So we have shader asset entries and then for each, and then we have our shader asset, yes. And in here we have the asset manager load. We load the shader program. And here we have a name for the shader. Okay. And we have shader program parameter. So this are the arguments for the shader program loader. And that one takes two kind of informations. It has the vertex file. And it has the fragment file, which is just a string. It's just a string. Okay. So we don't need this extension anymore, but at least we found it. Thank you. So it's just the strings and that's it. Then we load this bad boy up. And finally, so there's something special when it comes to shaders. There we need to check if they got correctly compiled. So for every shader, we need to get it. Yeah, we also need we don't have the getter operator here, so let's add that here as well. Operator function get with asset, which is a shader asset. That one returns a shader program. And that is basically return asset manager get asset dot name. I think we saved it via the name, right? Okay. Then we can also make all of this stuff to expression bodies, makes it a little bit shorter. Let me fix that quickly. Okay. Good. And that one returns the shader itself. Seems like it does not do that yet. Why? We have here a shader asset. And I have the get operator, which returns the shader program. Not sure. Here we want to have is compile. Okay, I need to fix that. Why is that not working? None of the following functions can be called with the arguments supplied. Get asset descriptor blah blah blah, get string. I don't want get string. I want this one here. Get shader asset. It's not from the asset manager, it's from our own class, of course. Okay, then we have if the shader is not compiled. So if there was a problem, then let me think, if we have multiple shaders, maybe we want to print the errors immediately for all shaders that could not be compiled instead of getting them one by one. So I would say make it here so we filter, or differently, we map all of the shader assets to the shader program. Then we filter for all of those where they are not compiled. Filter not compiled. Then we map them. Do we map them? No. For each of those, so failed shader, we then... No, we really map it. No, we don't map it. We have then log dot... Do we have a log here? Not yet. So let's make a log, which is our logger for the assets class. Yes. So in here we have then log.error and then shader blah 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 failed shader dot log. So shader, is there also more information? Like the name, fragment, shader, source. The source maybe. Okay. We need vertex shader or source, the entire source code. The source of the vertex shader. Okay, that's too much. We need two things. We need the name. So we will say here it to then filter not it dot second. Okay, that's not so easy to read. Let's make that then here shader assets and the shader itself. And that one we filter where the shader is not compiled. We don't need the first argument. And then for each, here again, we have the shader asset and the failed shader. And here we can now print if this shader failed to compile, and then we print out the log. And that's good enough. But somehow we also need to exit now the exit the application. So here we would need at the end, if not empty or something. So we need a little intermediate storage where we have the failed shaders by asset. And then if is not empty, then throw an error. Some shaders would not be compiled. Check the log. Why not use Kotlin built-in check message? What is the check? No documentation. Throws an illegal state exception with the result of calling lazy message if the value is false. Illegal state exception. Okay. Can that also throw a different exception? Because we... Not sure. I think we prefer a GDX runtime exception. That's why I call here GDX error. So that throws a... Let me download the source. I think that one is throwing a GDX runtime exception. Yes, so this one throws a GDX runtime exception. I think illegal state exception is also a runtime exception, but I'm not 100% sure if that would cancel the program completely. But let's try out this approach here first. So verify that all shaders compiled correctly. Let's check it once more. So we have shader entries and we map them to the asset and to the shader program. Then we filter for all which are not compiled. We save them, and then for all of them we print out the log where something failed. And if it's not empty, then we throw this GDX error. That should already be it. Then let's go to our render test screen. No, not shader test screen. In here, we would now need the assets. Like this, right? And this is not doing anything. Yeah, okay. Then down below, we need assets.dispose. And for our shader, that one would be by lazy, where we get from our assets the shader asset, the flash shader like this. And in our show method, instead of this stuff here, we need to call load all. Yeah, let's see. That should hopefully still work. Unable to read file for extraction. Okay, something went wrong. Couldn't load shared library free type, blah, blah, blah. Blah, blah, blah. Ah, that's now related because the assets are also now loading the free type font, which is currently not working in our test environment, but let's also fix that. We simply, what did we do? We added here this GDX free type platform. I think that's all we need. So down below here in our test implementation, we also need this GDX free type stuff. And now it should work again. Yes, so that looks good. So our Flash shader is still working, but is now loaded via asset management. And now let's make also a test. So if we do something incorrectly here, so that should not compile and we should get an error. So shader Flash failed to compile, fragment shader, blah, 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 unexpected identifier. Something. So that's the log file. And then we throw an error. Some shaders could not be compiled. Check the log. Yeah, that could even be improved a little bit further. We could say here, following shaders could not be compiled. Check the log. And here we have our failed shader by assets and map like this, like that. Okay, that should be it. Let's make one more test. So now I should see the shaders which are failing. So following shaders could not be compiled. Check the log. And there we have a list of shaders that are not compiled, which is the Flash shader in our case. And we also have this information here. So that looks good. Error handling, in my opinion, is good enough. So with that, we actually have our Flash shader available. And I want to make an initial commit for that. Let me quickly check if all of that is worth committing. That looks good. Then we have the different shader programs. Yes. We have the shader test screen. We have the test launcher. And something in tiled. I think in tiled we don't need to commit that. Okay, so add Flash shader and shader test screen. That first log seems unnecessary though. What do you mean? Yeah, if you read, I mean, I don't know if I get you correctly, but I would agree we could combine all these messages and then just throw one exception where you see the entire stack trace. That would be even better. And we could also have a chain of events, right? Maybe something like, wait, let me remove that once more. One final approach to optimize that. So map shader failed to compile. Then we have the log information. No, we don't want to log an error here. We want to just get the string out of it. And maybe, I don't know, 2 empty lines, something like that. And finally, isn't there an if not empty? If empty, do something. If present, do something. Why don't I have that? That's interesting. So I would maybe have something like this. Shader errors. And if shader errors is not empty, shouldn't that be... That's a list of strings. Yes, that makes sense. Shader compilation errors. And then we just print those. 2 nitpicky. No, you are never too nitpicky. We need to do something. Or we can always improve on our code. But I would actually... Why isn't there a if empty? Yes, but shouldn't there also be a if present or if not empty or something? That's a little bit weird. I thought that's available. One final test. So we will make that fail again. How does that look like now? So we now get shader compilation errors, shader flash failed to compile, and then the little information that we have here, and there would be multiple of those. Yeah, one more thing that we could do. So we have a list. So we can, how is that called? Join to string. I think that's the one that we need. And our separator would be 2 new lines. So if we would have multiple shaders, then they would be joined together to a string. Can also do it like this. And there will always be 2 new lines. Let's make it 3 new lines between the different shaders when they fail. And we can also remove it here. And that is now good enough, right? Shader compilation errors, shader flash failed to compile. Then we have the log file with something, and below we would have multiple messages. Okay, that's a little bit shorter. We don't need the log anymore. And we live with that. If you know how I can get here, like a if present or if not empty, something like that, that would be better. Then we don't need to like abort the call chain here and can directly throw this error. But if not, we just have this if here, whatever. That's good enough for us. One more thing. We will, first of all, remove this one here. Then we commit that here. And now you get advanced Git features, something that you have never seen before. We will squash 2 commits together so that when we push it to our repository, the 2 little changes that we just made is now just 1 change in the Git history. Great stuff. Good, then let me check. Damage shader. Make player white when he takes damage. So the shader is done, but we did not add that yet to our game. So how can we do that? My idea would be that we most likely add a component which we call flash, for example. And when an entity has a flash component, then it gets rendered with the flash shader. And if it has no flash component, then it gets rendered with the normal shader. I think that should work and should be fairly simple to implement. So what we need an additional component, which we call flash. And this component, what kind of information does it need? It needs a color, which is the color for the flash, and it also needs a I'm not sure. Maybe the weight, but we also need to somehow tell it how often should it flash in red and so on. And there we implemented something yesterday. How did we call that? Blink, right? So there we had the maximum time of the flash and the blink ratio and the timer. So maybe we need the same thing here. I would say. So you can say flash the player or flash an entity with a specific color. For how long? Then how or when should a flash happen? So when should it become red? Or according to the flash color. Let's call that flash ratio. And the timer which is needed to reset the flash, right? Let's try that. Let's see if we can work with that. But that also means that the system is most likely very similar to the blink system. Let's see. But instead of iterating over everything that has a blink component, we need a flash component. And we don't really need a graphic, but it makes sense that there should be a graphic. Yeah, so let's keep that. Okay. So that would be flash component. Then we have the color, maximum time and blink ratio. And do we need the sprite? We don't need the sprite at all. That's not important for us. Then if the maximum time is smaller than 0, then the flash is done and we can remove it, which is basically just removing the flash component. And otherwise, we reduce the maximum time. We increase the timer. If the timer is greater than the flash ratio, then we set it back to 0. And let me think. And here, most likely, we want to have the flash weight, right? So the flash weight, which we currently don't have, is then this one here. So if the weight is 0, then it's 1, and otherwise it's 0, something like that, I would say. So we need one more. So that is the uniforms that we pass to the shader. And that one would be the flash weight, which is a float. Okay. Would be then like this. I think that's already it. Then let's go to our game screen. Then, for example, here we can add the flash system. Yeah, not sure if that will look good. Maybe that looks like total garbage, but let's see. And now we have the system in place. We do something with it. And finally, in our render system, there we need something special now. So first of all, we need access to our shader, which is from the assets that we get in here. No, we don't get that. So we would also need here, we don't need to store them, but we need the assets, which we inject. And from our assets, we can get the shader as the flash shader. And what else do we need? We need the flash shader color location, I think. That would be the get uniform location of whatever that was called. Let's see. One is called flash color. And the other one is called flash weight. So let's call that, that's a little bit too long. U location flash color and U location flash weight. Okay. And finally, when we are rendering entities, only here we want to do something special. What could be very bad in here and could be optimized further. Imagine we have, for example, 10 entities and every other entity has the flash component, which would mean for every entity we will change the shader. One without the flash shader, the next with the flash shader, next one without the flash shader. So we will do a lot of flushing to our sprite batch, which would not be good. But in our game, I guess most likely just the player mainly will flash and get this component. So in worst case, we have 2 flushes from a normal one to the player and then back to a normal entity. And I think that's good enough. So could be, of course, further optimized, but I think we don't need that here. And in here, there we now want to do something special. So let's first of all get here the entity. And if, let's do it like this. So entity get or null the flash component. Flash component. And if the flash component is not null, then do something, and otherwise do that one here. Okay. Let's see. So if the flash component is not null, what do we want to do? We want to set the shader something like this. So if batch shader is not equal to the flash shader, then we set it to the flash shader. And we also set the uniforms like we had it in our test screen. So those 2 things here, all of that stuff. So flash shader use. And there we set then from the flash component the color and from the flash component the flash weight. And here we have now the optimized version. So we have the location of the color and we have the location of the weight. Okay, so if it has a flash component and the shader is not properly set, then we set it. We set the uniforms. I think the uniforms must be set outside here because can be different for different entities and does not depend on setting the correct shader. And finally, when we are done, I think we don't need an else here. So at the end, we always just render the sprite of the entity. That does not change. That's the same. And if it does not have a flash component, then we check is the shader equal to null or is not equal to null. Then we set the shader to null. And that should be it. There could be one problem now. So if the last entity that gets rendered has the flash component, then the shader would be the flash shader. So I most likely will, we will make an extension function in here. Let's call that private patch reset private function. Batch reset shader. And we have then something like this. So if the shader is not null, then set it to null. Which means in here we just call reset shader. And we need to do that all the time. So when entities are rendered, render entities, let me check. At the end, we need to reset the shader here so that our tile map itself does not get rendered by accident with the flash shader. I think that should be it. Let's try that out. No, that cannot work yet because we never add the flash component. So we need to go to the damage system. And let's see, maybe instead of having here the blink, let's add here the flash component for now with color is color red. And the weight is nothing. Flash ratio. But no value passed for flash weight. Okay, so flash weight would be 1. And that should be it. So let's try that out if that is working. So we have currently normal rendering, that's good. And now when we take damage, we are flashing. I'm surprised. Seems like it works. I'm very surprised. Okay, that looks of course like total garbage. I don't know, maybe should we just flash once? What would be a good graphical representation for taking damage? I'm not sure. Or maybe slowly go from the red color back to the original color? Is that maybe a better effect instead of flashing or blinking? Because that does not look good in my opinion. That looks a little bit stupid, right? The man with the great machete. Does anyone know the movie Machete? The most garbage movie ever, but fun to watch. Is there a benefit in performance if developing in Kotlin for video games? Or why is it beneficial to use Kotlin for games? To be honest, if you use Kotlin for games, it's a very bad decision in my opinion, because it's definitely not as performant as C++ or C. So if you really want to have a very performant game, a AAA title with the most modern graphics stuff and all of that shit, then don't go with Kotlin. That's definitely not a good idea. But if you're just interested, I would say 2D games, most likely, they should not be that critical nowadays with the hardware that we have. And if you just prefer to not think too much about memory management and have it simple, keep focus on your game logic and everything, then, and also if you are already used to Kotlin or like Java, for example, then I would suggest Kotlin. Flash quicker. That one we could try out. Let me first sit down. Kotlin is a great language and the tooling is good. Additionally, IntelliJ is an amazing IDE. We are not biased here, but let's be honest, it's the best IDE. Just kidding. I had this opinion a couple of years ago. Nowadays, I have a little bit of a different opinion about IDEs and code editors and everything. If you're interested, I can share it with you. So you mean we should flash more quickly, which would mean maybe 10th of a second and just flash for half a second, maybe. Let's try that out. Looks a little bit better, but It looks like it's only flashing 3 times, but I actually expected it to be at least 4 times. 1, 2, 3. It's so fast. 1, 2, 3. Oh, a little bit too fast. But that might be already good enough, right? Let's try a different weight as well, so that we are not completely red. Then this one I think is good. Let's reduce that to 0.4. Does that look better? Are we happy with this result? Maybe we should just blink once, to be honest. Just to indicate, hey, you took damage. That should be... Maybe we don't need the time thingy at all. I mean, that's the most flexible one, but for flashing, we might not need it. So let's say here, just a little bit more than the flash ratio. Now we should blink just once. Now I understand also the logic. I remember it. We have actually a delay. So the first flash... The first flash is happening after that initial delay, this flash ratio. And since the max time is then over after that, we just flash once, but we have actually this delay. If I understand it correctly. So if we would say here a flash ratio of 1 and maximum time of 1.5, for example, we should flash once, but after 1 second, which is maybe not what we want. Okay, I'm wrong. Why am I wrong? Because we add the component immediately and then we already render it. Yeah, okay. I think I get it. But let's change that. I think what we had before, that we just flash once. I think that's the best thing that we want to do. But we need to change the code a little bit. Maybe also, I don't know if we can combine it with the transparency. Let's see. At Quillrim, I would prefer to flash once, because as soon as there are more enemies, you could run into the problem of overlapping flashing. Yeah, so I also would say just flash once. But let's change the code here a little bit. So instead of doing it like that, what would we actually need? So we have the color, the flash weight, then maybe the flash amount would be just flash once. That should be an integer. And what else? Flash delay, something like that. And there we would say 0. Okay, no, let me implement it like this. So let's say we want to flash 2 times, or to make it easier to debug 3 times. And there should be a delay of half a second between the flashes. We will change that then later on to our correct values. But I think that is something that we want. Let me think that through now. And oh no, we also would need to know how long should a flash be. So how long is the flash effect? Because currently it's permanent as long as we have this component. And in the end, we don't want it to be permanent. So we need those 3 values, right? So how many times do we want to flash? What should be the time between the flashes and the, let's call it flash time. That would be, for example, like, I don't know, quarter of a second, something like that. Yeah, then I will get rid of the flash prefix because that does not make sense. in my opinion, unnecessary because we are in context of the flash component. So we don't need to add flash everywhere at the beginning. That's unnecessary. But that should be it. So this is the information that we want. So we have the color, we have the weight. I don't refactor here on purpose because I want to see if anything fails in the code and then adjust the logic because I'm modifying the logic now completely. So I want to identify all the locations where I use those variables and make sure to fix them correctly. So we have a color, we have a weight, we have the amount, which is an integer. Then we have the delay, which is a float, and we have a time, which is again a float, and no default values because all of that needs to be provided to make a flash happen. Then coming back to our flash system. Here we destructure now, of course, differently. So we don't need the color and the weight. They are only important for the rendering, but we need an amount, we need a delay, and we need a time. And for the delay, we actually also need an internal timer. Delay timer. Yeah. Okay, then. So first of all, if the amount is smaller than 0, then the flash is done and we can remove the component. That makes sense. Then otherwise, what do we do? The delay. We also have the timer, right? So let's also get the timer here. How did we call that? Delay timer. So if the delay timer is 0, then we set it to the actual delay. And what else? I think that's it. And also from that delay timer, we reduce it by delta time. Oh, and also when we reach 0, if we think that through, then we also need to reduce the amount by 1. Yeah. I see that you are writing comments, but let me read them in a moment. Let me think that through first. So when we don't have any flash amounts left, we remove the component. Otherwise, we have this internal timer, which is initialized with 0. It should be maybe initialized with the delay amount, I would say. Which means we get that in here and it's greater 0, so we don't end up here. And what we then do is we reduce it by the delta time. At some point, this delay timer is 0. Yeah, which means we now want to flash. So the delay timer gets increased back to the maximum amount. We reduce the amount. And now somehow we want to indicate that a flash should happen for that given time. So we would need also a time timer. The namings are completely crazy, but we would need something like that. And do I really need that? Okay, let me first of all get rid of that. Somehow in my render system, I just need to know now, should I flash or not? And it's not, so having the information that an entity has the flash component is not sufficient. We also need an indicator that the flash should now really happen. And I want to solve that via this time. Maybe it's a little bit too complicated what I'm trying to achieve, but let's see. So we have the time and we also have the time timer. Like that. Delay timer and time timer. So again, let's think that through. I add this component to an entity. We go through this method. We have an amount greater 0 because we want to flash. So we execute the logic below. There we are reducing this delay timer. And once the delay is 0, so there's, let's say we have a delay of half a second. So if that is reached, then we want to flash. So we reset the delay timer to repeat this process again and again. We reduce the amount because we are actually really flashing now one time. So the only thing that we need now is we need more like a flag, right? Maybe this piece of information is currently missing. So now I want to set something like do flash equals to true. And to know how long it should flash, we would need a separate logic. So when it's now flashing, we would need to reduce this timer for the flash. Wow, but that's weird. Isn't that completely weird what we are doing? Let me read the comments. I think another common effect is flashing into transparency and back. By the way, your tree destructuring will break if you change the order of two fields with the same type. Yes, I know. So the destructuring needs to be in the correct order, but normally I get a warning in the IDE. So if a name is not consistent, then it tells me, hey, you referring to, for example, the delay via the amount attributes and things like that. So I get there a warning. That should be okay. I'm thinking now that I think that's too complicated. Let's make it a flash. How many times? Maybe 2 times. And how fast it should be. I think we reduced that piece of information. So we just have how many times, the delay between flashes, but still we need I think we need this information here. So do flash, which is a Boolean, and by default it's false. Or by default it's true, so that we immediately start with the flash, and we call that now with it will keep working correctly. I know, but I just I like destructuring, and since I used it everywhere so far where I could use it, I don't want to break the convention now. How do we call that now? So color, weight, amount, then the time. Oh, what did I say? I already forgot it. Yes, it's then the delay. The delay and the delay timer. We keep it like that. Coming back. So now hopefully I can simplify that a little bit. So again, color and weight is not important. We have the amount, we have the delay, we have the delay timer, and the do flash we are not interested because we are going to set that. So all of that remains the same, I would say. But this one here actually needs to be toggled. So it's like this, right? I would say so. And the amount gets then reduced. Does that make sense? And the amount gets reduced when do flash is equal to true. So when we actually did a flashing, then we reduce the amount. And we need to check that before we toggle it. Like this. Let's see, that might do the trick. We have here the delay. If delay timer so the delay is actually then a constant value. Yes, like this. Okay. That should be it. And finally, in our render system, we need something differently. So here, if the flash component is not null and the flash component has this do flash set, only then we are going to flash with a specific weight. Otherwise, we use the normal rendering stuff. Okay, let's see. So what we have red, we have a weight, we want to flash 3 times, and we want to have a delay of half a second. So we would expect now 3 flashes. Let's make it 1 second. Let's see, that would be the expectation. 3 flashes in red. And it never ends. Okay, that's not working, obviously. Why is it not working? We have... Let me think that through once more. We have our delay timer, which gets reduced every step. So at some point we should enter here when we have do flash, which is initially set to true. We reduce the amount. We set the delay timer again to this maximum amount. Let's make a breakpoint here. And we toggle the do flash information, which would be false. So the next time we enter here, this one is not executed, but flash gets set to true. So the amount should get reduced all the time. And it looks like we never end up in that code here. That's interesting. So we have a delay timer of minus... I'm a total retard. Never make floating numbers compare with an exact value. That will never work. That should be less than 0. Yes. 2 times, 3 times, done. Yeah, that looks good. Let's make also briefly a debugger. Will delay timer ever be 0? No, of course not. Okay, flashing is now done. I would expect I'm never ending up in this system. Yep. So component got removed. That's the problem. So with floating point numbers, they are never accurate enough. So either we would need to compare it with a tolerance, like we have it in the mathutils is equal, and there you can pass a specific tolerance for floating point numbers. But in our case, we don't need that. Basically, when it's less than 0, so the timer has run out, then we want to do this little logic here. Okay, now let's change that. So since that seems to work, we want to flash just once, and we want to flash for half a second. Let's see. I think that's too long. Let's make it a quarter of a second. Yeah, even that looks a little bit too long. Let's make it a little bit more than 10th of a second. Yeah, that looks good. Yeah. That looks perfect. And now I'm wondering, can that be combined together with the blinking stuff? So what's happening now? So we see the flashing, and we also would see the blinking. The blinking is maybe good. Yeah. So the blinking indicates for how long we are invulnerable. So that's this 1.5 seconds. I think we keep that. And the flash is to indicate that we took damage. I think let's be honest, it's not perfect. So we could play around with that and optimize the effect even further. But I think it's fine. Maybe one blink. Let's make it with the flashing. Let's try 3 damage blinks. It's a little bit weird. I personally, I think we should just blink here once, but the blink ratio maybe should be faster. Not sure. It feels a little bit weird. It does not feel like something nice. That looks better. I don't know if you see that on stream, but the quicker blinking looks now better. So we blink red once so that we took some damage, and then we are blinking something else. Whatever, it's not perfect, but we made it happen. So something that we could play around with, and I will finish that here with now. So damage shader is done. Looks great. I know that you are lying. I can see that. The sarcasm between the lines. Yeah, that's perfect. So now we would also have a hurt animation. And I'm thinking if we should apply a force. Let me quickly try something out here. If that would work like I thought it could work. So body, apply force, and then push it to the left side with, I don't know, 10. Not on the y-axis. And apply it to the... let's make it like this. Vector 10 minus 10f, 0f. We need here a run method because we need the body once more. So body or center, world center. And what else? Wake the body up. Something like that. I want to see if that would already work. Would that push the player now away a little bit? Does not seem like it. Either it does not work or it does not do anything. Let's make it a bigger force just to be sure. No, that does not work. And why does it not work? Because we are... I think that's now one of the issues that we have with our approach. Since we are setting the linear velocity here directly, we basically overrule the whatever forces would be applied in the real physics world. So gravity and also these forces now or impulses, they are basically nullified because we set the linear velocity values directly here. That's the downside to this approach, but for sure I will not change this approach now. But something to remember for a future project. Now, how could I easily fix that? Maybe we just don't do that then at all. Maybe we just play the hurt animation and that's it. I think we will do it like that. The animation I want to play, but the force simply does not work with the, or not so easy with the approach that we used. One solution would be what I can come up with, that we have like a pushback component or something like that, where I specify the force that should be applied. And then in the physics system, when I set here the linear velocity, I also take into account the values from the force component or pushback component and simply add that up to the vertical X and Y value. That way I can again apply some force to my entities, but I don't want to implement that now, and I think it's not really necessary. I was just interested if that would work. That's why I added here this remark here, but seems like it's not so easy to do. However, how can we play a different animation? So I would say if the entity has an animation component, then we want to do something with it. Because I want to set here a different animation. A good question. Currently our animation, let me first of all commit the code to be safe that we can always revert to a working state. So that one is done. We had the flash component, the flash system, and we updated our render system to use the shader with the correct uniforms and everything, and that seemed to work. So add flash shader when player is hurt. Then let's commit all of that stuff. Okay, coming back to our animation. Currently, we handle animations via a state. So whenever we are in a specific state, we are setting an animation. Like when we are running or jumping, we would set, for example, a jump animation. Which means if I would now manually set an animation, that simply doesn't work. I think that would not work, because for example, if I'm running inside an enemy, then I would play the hurt animation and I would then start a jump or stop moving or whatever. I would go into a different state, which means I simply override the animation. So instead of having then the hurt animation, I would immediately have the idle or jump animation or something like that. So somehow we would need an animation that is on top of everything. Like a global animation. And if I set it, then this call here will not overrule the current animation. So what we could do, let me think that through. Currently our animation component has this type of info. What we could do, since we have flex, we could actually have two different types. We could have a normal animation and like a global animation, let's say. So the same component, but added 2 times to an entity with different purposes. And in our animation system, we could then check here. So if the entity has a global animation, then it plays that one. And when it's finished, it simply removes it, for example. And otherwise, it will play the normal animation. So that could be one solution. I think we can try that, because that would also be a good reference in the Flex Wikipedia to have an animation example with different types. So what I'm thinking of, how did that work? I think here we have now 2 of these types. So the first one would be the, let's call that normal animation. That is one component type. I think we need to make that here an object like this. And we have a global animation. Something expecting a class body. Is it like this? I think so. But let me quickly, just to be sure, let me check the documentation how to properly do it. So we are here. We need to go to the Wikipedia, and I think it's maybe here under component. There is a method component type of. That's the correct way to do it. Okay, then component type of animation. Okay, so that's the short version for this object with the body at the end. And now here we would also set the type, which is the component type of type animation. And I would say set that correctly and then return it. Okay, so somewhere in our code we currently have, I guess, animation. Yes. Oh, let's see. Can I get it like this? So usages in our project, new instance. Yes, I get it out like this. So first of all, in this render test system, there we would have now the normal animation. I think we called it like this. Do I need to say here type? Okay, like type equals something. Okay. Then let's copy that once more. That's just for the test class. What did I do here? I think like this. Okay, so the test class here should be fixed again, the render test screen. And finally, also in the core project, one moment, I read the comment soon again. Here we also have that this is the normal animation. Okay, and what I want to do now would be something like in our damage system in here. I would add another animation. But this one would be like the global animation. So that would be the idea, to have something like that. Okay. Hello, Mark. I actually used AI to help create some shaders for my game, like my dash and background. Are you the guy that sent me the game in Discord where I was able to play around a little bit with it? Where you could attack some enemies in a world and then dash around and jump and things like that? Then I remember you, and I think you mentioned that, yes, because I asked you how you. Yes, okay, so you are that person. I remember that you told me you created the shader with some AI stuff. We also took the help from AI today to create our Flash shader, which is already working, which is good. Okay, so once more, in here, we want to create now a GDX animation for the hurt animation or hit, we call it like that. And the game object would be, do we store that on the tiled component? Yes. Let's assume that it's like that. Okay. Then let's make it a little bit nicer. Let's say it is like this. And this could also be maybe created as a separate extension function to make it easier to read. But anyway, let's try to make it work. So what we need now, our animation system does not compile anymore because we have now a different family. So we iterate over all entities which have a graphic component and which have either a normal animation or a global animation. One of those two. And now our logic here would be a little bit different. Where is that one called? World Entity Animation. We call that on the AI part. Okay, let me think. So in here, we always are interested in the normal animation, I would say. Because that one is just AI related, it seems like. And here we want to distinguish now. So entity, get or null, and then we want to have the global animation. And if the global animation is not null, then update global animation and remove component when it is done. And otherwise, update normal animation. So that would be the logic that we have here. But that would mean actually our family does not change. So it must have a normal animation. That's important. The global one is optional. So that one we can remove. And now let me think it through. The global animation. Why would that ever stop when we take damage? Currently it won't stop. We would also need to set the play mode, which is play mode normal. That means it just gets played once. Okay. So back here, we would then go in here, but it's exactly the same codes that we have here, right? Yes, I think there is no difference. So we will have something like update animation component. And there we simply pass in the animation. And we do something with it, which is this thing here. So we can call that animation component. That one gets removed. And the code would be also from the entity. Let's see how do we want to call that? So the simple approach would be to pass here also the entity. Okay, and then do that stuff. And finally, we can remove that here. And what we would do here, so here we would call updates animation component. We pass in the entity and we pass we already have that. We would pass here the global animation component and return. That's it. And if we don't have a global animation, we would pass here the normal animation component like that. So in theory, that should be it. I want to call that a little bit differently. So I would like to have that as an extension of the entity and call that updates animation. Then we can call it like this. So entity.update animation, remove here the first argument. And also here, entity update animation. And call it like that. Okay, so that would be now, if it did not break anything. When we get hurt, we add a global animation and we should play this, what did we call it? Animation hit. I'm not sure if that is the correct name of the region in the texture atlas. Let me also quickly check that. We called it hit. Okay, that would be the hit animation. It gets played once because we have play mode normal. And, oh, I forgot something. So in our animation system, update animation, and we would need to something like, so global animation components, is animation finished? And the state time is the timer, I guess. So if it is finished, then we remove it from our entity. So the animation is done. So we remove it and we return then to the normal animation. So now that should theoretically work. Let's see. So let's get hit. I saw it. Yes. Yes. Yeah. Amazing stuff. So I see that he has this hurt animation now, and then we are returning to whatever we have. I think it's a little bit weird maybe that we can still run while we are hurt. But those are some minor details. The animation is played, which is cool stuff. So we can overrule now the normal animation management from our state management with something that we want to set. And it's a good example then also for the Wikipedia page on Flex, how to reuse the same component like we do it now. So this, coming back again once more, so this animation component here is now used twice. So the same information, and actually the same system is processed, but we can add the same component multiple times to an entity, once as the normal animation currently, and the other one would be the global one, which is overruling the normal animation. So that is good enough. I would say that looks good. So let's also tick that off from the list. And here, force does not work because we set velocity directly and overrule gravity, force, impulse. Goody good. What happens when you jump on top of the enemy? Global and normal sound confusion, by the way. What? What do you mean with that? What happens when you jump on top of an enemy? So there are currently two different kinds of enemies in the game. The first one is this rocket. So when I jump on top of it, I can basically stand on him, as you see here. So there is a collision happening. And there's another type of enemy, the saw, which is following the track. And that one is just a sensor, so there is no collision happening. So they are just going through the player and damaging him, but you cannot stand up on them. Initially for the saws, you were also able to stand on them, but I did not like that. Felt a little bit weird. So they are really going through the player, but the rocket, that in my opinion makes sense that you can maybe stand on him. That is possible. What I notice now, and that is also something that I would definitely fix in a real game. What would be more natural is that when we are on top of our rocket, which is a kinematic body, that we are actually moving with him to the right and left. I think this is maybe also simply not working because, again, we are setting this linear velocity directly. So I guess the physics simulation would correctly push us with the kinematic body if we are on top of it. But since we are overruling the linear velocity, that is currently not working. And what we would need to do is most likely update or somehow tell our entity the velocity of the rocket and then also apply it to him. So in the end, I think we should have went with the approach that I normally use. So use impulses and forces to move the physics body around, because if you set the velocity directly, you simply bypass certain things of the physics simulation, which would be nice if we have them. But yeah, we went for that approach for now, and it is what it is. It sounds like the animations have priorities, but you named the priorities normal and global. It's not clear which one has a higher priority. Yeah, my thought process was related to the default state machine that we are using for state management. And in here, you also have something which is called a global state. And the global state of the owner, its logic is called every time the state machine is updated. And from what I know, but let me quickly check that. Is that just separately? That's separately. So you can have one global state for the state machine, which gets updated, but you can also have a current state. So the current state is what we are currently having, and there would be in addition a global state. I use, for example, for a global state, usually if an entity is alive or not, because that is on top of every other state. So if an entity is dead, then I don't care about what is happening below, if it should run or jump or whatever. We don't care about it anymore because the global state, which is no matter in what state I am, I can be dead or alive. So that would be, for example, a global state for me. And that's why I use this naming convention. But yeah, that's why I called it global. So global has a higher priority than normal. But of course, we could rename that. Give me some better names and I can rename it. I don't know. Normal, global. I don't have good names for that. So let me know in the comments if you have good names. Then we can add that. Now, a small little fix. And I think that's the last one for today. What do we have on the next day? This double jump feature. I think this optimized jumping, we will move that to the next day. I'm happy with what we achieved today with the shader and everything. I did not expect it to work so fast. Also, herd animation is playing, where I also did not know how difficult that would be. The last thing would be to add a map boundary that we cannot go off screen. And for that, what can we do? We can... Wait, first of all, we need to commit the code changes again. That we have a working state. Yeah, all of that is okay. Let me quickly test something because we modified one of the tests. Just want to make sure that they are still working. So a render test screen, that one should hopefully still work. No! Asset not loaded, graphics, game object atlas. Why? That's a good one. Why is that not loaded? Ah, because I think initially we did that immediately with loading everything, but now we don't do that anymore, which means I think this screen is simply broken. Let me quickly check. So somewhere we access here a region, but I think we never called load all. Yeah, we did not do that. So let's do that here, I think. Assets, load all. Still not working? Why? Texture region. Ah, that one gets created already here at the top. Then let's call here load all. Hope that works. No. There is no injectable with name UI viewport registered. Aha, there's also something missing for the render system. Okay, so we broke here a couple of things in this test screen. Let's see. We also need a stage. Wow, we need a lot of things. Good question. Let's see, is there another test screen where we have everything working? No, I think the jump test screen most likely is also broken. Okay, let's quickly fix the test screens that we have here. So for that, we go to our game screen and just take over some of the values that we need. It's not super important, but it would be nice if we can run the different tests that we have prepared at least. So we have a UI viewport and we need a stage. Is that everything? Yes, so that one is now working again. Good stuff. And we also had a jump test screen, which I guess is also not working. There is no injectable with name audio service. Okay. Let's see, audio service. I think that's an object, right? No, it's a class. Where do we create the audio service? I think in our main application. Yeah, like this one. So let's make that here. In order for that to work, we need assets and game properties, which is here. That's just some quick and dirty fixing. And then we had the method load game properties, which we need to make public now. Or do we even need that? Okay, let me quickly copy that over as well. Okay. Perfect. So this screen is also working again. Good, good. With that, let's commit that. Add hurt animation to player when he gets hurt. Perfect. And now coming to our map boundary issue. So that's the last thing that we are going to solve today. Currently, we can run off the map to the left side here. Then we can also fall down to the bottom here, which is also not ideal. We can go to the right. At the top, I think we don't need a restriction. But on the left, right, and bottom part there, I want to have some boundary that as a player, you cannot go off the map. That does not make sense. And to solve that, let me think where we are going to do that. Maybe in the tiled service as well. I think that is the best area to do it. There we have an on event where we react to a map change event. And now let's simply do two separate things. First of all is the spawn the entities. And the second thing would be to spawn a map boundary where we pass in the tiled map as well. And in here, what do we need? We need actually 3 bodies. We could actually just make one body. Create one chain shape for the map boundary. Left, bottom, and right edge. Which means we need from our physics world, we need a new body, which is of type static and which has a specific shape, which is a chain shape, where we need to pass the vertices and that's it. Yes. And the vertices are of type float array, right? Or what was it? I think it's all vertices equals float array. And what do we need here? So let me think that through. Left side is pretty obvious. So bottom left would be from our, so the x coordinate is 0 and the y coordinate would be from our tiled map, the height. Yes. To float. Then the next point would be 0, 0. That would be the bottom left corner. Then we have the tiled map width. That would be bottom right. And finally, the top right corner. that should be it. 1, 2, 3, 4. So here would be top left, bottom left, bottom right, and top right. Okay, to check if that is working, let's add here a 1 to it, that we see it inside the map. And here let's add a -1 that we also see that. And the bottom, let's also increase it to 1. Something like that. And finally, we need to turn on physics debug, that we see if that is properly created. Okay. Looks like it. So there I already see a line where I can go through. Because we needed a box. I remember. Since our player is a chain shape. Let me go here. Since our player is a chain shape, it does not collide with other chain shapes. We discovered that at some point. But seems like we are correctly creating it. So there we have the right edge of our map, then the bottom edge, and finally the left edge. So that one, it looks like it's created correctly. But what we need actually a box. And let me think that through. The box is always located around the center of something. And our position is 0, 0. So it gets created around the 0, 0 position. Which is a little bit too complicated for me to think it through. So I would say here the position would be, let's make that map center X is equal to tiled map width and half of it, and tiled map height. And then the position is the map center. And finally, we would need a box around that stuff. With a width which is, I think, 2 times that one. And the height maybe also 2 times, if I am not wrong. I'm not 100% sure, but I think that should be it. Let's see. Let's try that out. That does not work, obviously. So the player gets moved. I could imagine the player gets now moved outside here. Because we are inside a box, so we get, of course, shifted outside. But then how do I actually restrict the player inside something? Because the chain collision does not work. Good question. Box 2D collision between 2 chains. I'm facing a new problem by using chain shape. The collision between 2 chain shapes body not happen as like normal body. So this is normal behavior. Am I doing any mistake? Yes, chain shape collision is not supported in Box 2D, but if your body is a polygon, you can create a triangular approximation for this and compose your body from polygon shape. Okay, so I guess is the chain creating a chain shape? Yeah, that seems like it's something separately. And what we would need is maybe something like a polygon, where I just pass in the vertices. Let's try that once more. Okay, let's try it. If maybe polygon is working. Let me think. I think it's working. Yes. So let me get inside the map. So the collision is definitely working. We don't come inside here, but I don't like it that the polygon is closed. Why is it closed? To construct fixtures with polygon shape. I pass the float array, and what is it then calling? Shape, set the vertices, and then it creates a new fixture and disposes the shape. But I'm confused. Why is it? It seems like it's going from the top right corner back to the original starting point. And that way the player can... I'm actually wondering, is it then the same behavior as with the box that we had before? I think it's the same behavior that we had with the box before, that the player then gets pushed outside of that boundary. That's weird. That's very weird. What if we do it the other way around? If, let me check. We have spawn entities, we have the ground bodies. The ground bodies are, what are they? They are something. So if they are a rectangle, then they are chain shapes. Yeah. And our player is... What is our player? Our player is a box. I'm thinking, what if we do it the other way around? So if the world contains of boxes and the player would be a chain. I remember that 2 weeks ago we fixed that or changed that. And oh wait, what do I want? I want the player to be a box and the world to be a chain. That is what I want. And what are we currently doing? Let me think that through again. So we have here our ground body, which is a rectangular map object. There we create a fixture definition out of it, where we end up in here. And in here we create, we check if something is a chain. And that one we set somewhere here, right? Yes. So here, the feet of the player is a chain. Yeah, that needs to be chains. I remember now, because not everything here is a box or a polygon or something, so it needs to be a chain. Okay, that's way more difficult than I thought it would be. I never had this problem for whatever reason. Hmm. What was the proposal here? But if your body is a polygon, you can create a triangular approximation for this and compose your body from polygon shape. That is what we are currently doing. In case anyone interested, I've added support for chain shape collision in my dev branch fork of Box2D. I'm not sure what version of Box2D now includes chain shapes, but it's in the documentation. Aha. So maybe that's nowadays supported, but not in the Box2D LibGDX version. Or we broke something with some other code. So before we had here the chain. And the chain... Now I have another idea. Since the chain does not work, we could actually make a box to the left, a box to the right, and a box on the bottom. Yeah, let's make it like that. That, I think, is the easiest solution. Create 3 boxes for the map boundary, left, bottom, and right edge. I think that's the easiest one. So we have a body, and this body has in total 3 boxes. And how do they work? Let's see. They all get positioned. Let's assume the center of the map is the body position. I think that is something that we need. So that would be from our tiled map, half of the width, and from our tiled map, half of the height. Okay. And now here we want, let's start with one box to see if that is working. We want one box which has a width of, for example, 1, a height of tile map height, and now we need to correctly move it to the left, so it needs the position. And there we go. Let's see, we go half of the map to the right. Would that be it? And let's remove the chain shape. Let's see. So I would expect that we see something on the left side. Yes. So we totally see something on the left side. Yeah. Annoying little rocket here. So we see something on the left side, but it's a little bit inside of our map. Why is that? Because it has a width of 1. And I guess it's centered again around something. So we would need to go a half of the width more to the left. So now with that, we should not fall off the edge anymore, right? Okay. It's a little bit of a strange behavior. Wait. Let's call that box width is, I don't know, 3 units. And we need to go half of this box width here. Then also that would be the map width. And that would be the map height. So we go half of our map width, or we go the map width to the left. And we also go box width to the left. That should now block us from falling off the left side of our map, right? Okay, that little guy here annoys the hell out of me, so we will remove him for now. Going left. I get blocked here. That looks good. And I get blocked up until here. And then I can go over this border because it's just the height of the map, but not more than that. Also, we can, for whatever reason, we can stick to it, but that one might be able to solve if we say here, friction is 0. Okay, then let's make the box height also bigger. So the height would be the... I'm not even 100% sure. That should be map height plus, I don't know, 10 additional world units, something like that. And this times 2, so something like that. How can we visualize that? So let me not position it properly. So now we should see a red line again. Yes, so this red line goes somewhere to the bottom and somewhere to the top. Can I zoom out here somehow? Let me check something. What happens if I say here game camera zoom equals half of it? What does that change anything with the rendering? Okay, now we are zoomed in. Let's say zoom 3. Okay, that's perfect to analyze it. Okay, so what we have now is on the left side, we have this box and it's higher than our map and it also goes a little bit below. I would actually want to have it at the bottom here. So aligned with the bottom left of our map. Not sure if we can achieve that. And move it up. Okay, let's see if we can fix that. So in here, I would assume we need here the map height in addition. Is that it? Yes, that looks good. Also, we cannot stick to this wall anymore. That looks good. And it's higher than the map, so we cannot jump over it and fall off at the left edge of it. Okay, now let me position it again properly. So in here we said we also need to reduce half of the box width. And now we should have the correct left edge of our map. Yes, so we cannot run off that anymore. Oh, and we can jump over it, but most likely that will not happen in the real game because we cannot jump that high. But let's make it then higher. Let's say here, I don't know, additional 15 world units. Then it's not properly located anymore. Why? So it's map height plus something. I don't know. I don't care. I think that is... Let's see. Let's zoom out even further. I think that's high enough. And it blocks us from the left edge, right? Yeah. Okay, I think the map stops somewhere here, most likely. I'm not 100% sure. So we can jump a little bit over the map, but that's it. So that's good enough. Now we have the left edge. Then the right edge should be fairly simple to add as well. So this is the left edge. Then we have the right edge. That's basically the same box, but we need to go to the right. That should be it. Yes. So now we cannot run off the map on the right side as well, which is also good. And finally, the last one would be at the bottom. So there we need the box width is actually the map width times 2. The height would be maybe this one here, so the thickness that we had before. And the position, that's now a good one. Where do I need to locate it? Minus map width and 0, maybe? Let me see, what does that give us? No, that's completely wrong. So it's definitely plus and most likely minus map height. Better, but also not correct. So that is 0. And here we, of course, also need to subtract the box width because that's the height of our box and have it like that. Yes, that looks good. So now we are at the edge here and we cannot fall below the map. But I actually want that, so that should be a little bit lower. And let me quickly fix that here to make that a little bit better. So for the bottom edge, the width is the map width times 2 and the height is the is 3. And now let's use here the correct values to make it not completely confusing. So here I said we will go down the map height and minus the box height and a little bit more. So maybe, I don't know, 5 world units, something like that. Minus, of course. Let's see. Yes, that looks good. So now we can fall off the map. And what I want to do, so when we collide with this map boundary at the bottom, then we want to kill the player and maybe respawn him at the original location. So something like that. Also, one more thing. So these boxes here, let's try to make them a little bit taller. Let's make it 20. Yep, that looks now good. So also when we fall down from the map, we can also still not leave the map on the left side or right side or whatever. So we are really restricted with our movement within a specific map. That looks good, I would say. That's perfect. So the last thing that we need to do is that those little thingies here, they need a user data for the future, which is map boundary. And let's copy and paste that here multiple times. I'm also not sure. So that is maybe map boundary left, map boundary right, and map boundary bottom. And that's something for the next day. Maybe here, if player gets in contact with map boundary bottom, then respawn him. Okay, so that is the first thing that we are going to implement. And on the next day, and for today, that looks now good enough. So first of all, let's bring back our little rocket here. And also we don't need to zoom in again because we saw now that everything is working properly. And also in the game properties, we don't need the debugging of the physics anymore. Let's make a final test. So what did we do today? We have this hurt animation and we flash red for a brief moment and blink for our invulnerability time. So that's more than good enough. Then we cannot leave the map anymore on the left side, which is also good. We can fall down to the bottom, but not forever. And we are also stuck on the right side of the map. That is everything that we needed. By the way, also there's something missing, which we did not implement yet and we forgot about it. Let's also do that here. Allow player to jump through platforms if he is coming from below. That was a question, I think, at the beginning, how to solve that. And I explained it how we will solve it, but we did not implement that yet. So that one we can also do then on the next day. Yeah, I would say I'm happy with the achievement for today. Let's mark it as done. And basically we would have now 2 more days left. Let's see, we have the respawning of the player. That should not be super difficult. Then we have this jump optimization. That will take a little bit of time also with that part here, but that's also something that I know already how we can solve it, so that should not be super hard. Then the double jump feature, that will be a little bit of a tricky one. I would say pretty sure that that's not possible on that day. So let's move it here. Then we need the parallax map background. Then a map transition. That will not be super fancy, but somehow we need to move from one map to the other. Maybe. But that's also for sure an additional day. So this stuff here will be a separate day. Then this one here, I think that's doable. That's also fine. And what do we have in our backlog? So the boss fight. We won't do that. I don't have time for that because I'm only here for about 2 more weeks. Then I'm on my holiday. And I'm pretty sure when I'm back from my holiday, I don't have that much time anymore to work on that project. So we need to come to a final state at some point. So the boss fight is something that we will skip. We won't have time for that. So let's mark it. Can I somehow make here a cross? Yes, that is what I want. Let me copy that. That's not going to happen, unfortunately. There is no time left for that. Then a safe load system, also not going to happen. No time for it. Then the GDX AI pathfinding, maybe, not sure. That one I will keep in the backlog. Then automatically update the enum stuff, also not going to happen. And change free type font to bitmap font. That should be something that we should really do. That would be cool because I want to activate the TVM backend. So let's bring that up here. That might be possible on that day. Let's see. And yeah. So that would bring us in total to about 3 to 4 more streaming days to finish this project. which means let me check my calendar. Because as mentioned, so on that week here, I'm going on holiday, so I will not be here anymore. And I don't have time on Saturday, so Sunday. So I will try to stream tomorrow and maybe Thursday or Friday, and also on Sunday most likely. So hopefully by end of this week we are done with the basic features. And then next week, if we have time and still motivation, we could maybe do this AI pathfinding stuff and make some beautification and finalization. But anyway, goal would be, let's always set a goal, which is important. Goal would be by end of this week, we are done with all these features that we are still not having yet. And right now, I would say that's a perfect point to stop the stream for today. We achieved quite a few things. Add map boundary bodies to avoid falling off the map. Yeah, so if we compare our game from like 2 weeks ago, I think that's where we started. And what we have now, that's quite something. So we have some user interface basic stuff, we have some movement, some jumping, we have collision handling, we have 2 kind of enemies which are not perfectly implemented, but it's a very good starting point and reference. So we have these rockets which are moving in different locations with the sensors. We have this flashing shader that we see some hurts, so that we see when the player is hurt, that he's tinted or rendered in a red color. Then we have our saws, which can be either stationary, like this saw here, or they can follow a specific track, like here, that one is going up and down. That one here is going in a little bit of a different shape. We have the boundary of the map that we cannot run off it. And yeah, I would say, we also have this indicator with our hit points, which is also good. So I would say that's actually quite something that we achieved, and I'm happy with it. Also seems like we optimized it fairly well, because we just have 6 bindings and 6 draw calls. I think that's good. Constant FPS of 120. That is just simply because my monitor is capped at 120, which is also good enough. So everything seems good. And with that, I am thanking you guys again for watching, also for helping again with some of the questions that I had. And most likely see each other tomorrow in the evening stream session. Have a nice rest of your, what is today? Today is Monday. Rest of your Monday, and bye-bye.